Hidden beneath Jupiter's shadow lies one of the most fascinating worlds in our solar system, the Moon, Europa. At first glance, Europa appears as a giant marble floating in space, its surface a maze of intersecting lines and cracks stretching across a gleaming white landscape. The Moon's surface is a shell of pure water ice, estimated to be between 10 to 15 miles thick. This shell is not uniform. The top layer is brittle and cold, while deeper ice becomes increasingly warm and flexible. These dramatic lines aren't just simple cracks. They're complex geological features called lineae. The reddish-brown coloring within them suggests the presence of mineral salts from the ocean below. But what forces could create such a dramatic landscape? The answer lies in the immense gravitational influence of Jupiter itself. Recent images from space missions have revealed regions called chaos terrain, where the surface appears to have been broken apart and refrozen, like pieces of an enormous jigsaw puzzle. As Europa orbits Jupiter, the ice shell flexes and stretches. This constant motion causes the surface to crack and shift, creating the intricate patterns we observe today. Some of the most striking features are the double ridges that crisscross the surface. These massive formations can rise hundreds of meters high, comparable to the height of some of Earth's tallest buildings. These surface features tell us that Europa is far from a static, dead world. It's an active, dynamic moon with ongoing geological processes. The variety of surface features we observe, from smooth plains to jagged ridges, from dark bands to chaos regions, suggests a complex and active world that continues to reshape itself even today. The relationship between Jupiter and Europa is like a cosmic dance, where the giant planet's gravitational influence shapes every aspect of this icy moon. Jupiter's mass is over 20,000 times that of Europa. This enormous size difference means Jupiter's gravitational pull has a dramatic effect on its small companion. As Europa orbits Jupiter, its distance from the giant planet varies slightly. When closer, Jupiter's gravity pulls harder. When farther, the pull weakens. This creates a continuous cycle of stretching and squeezing. This gravitational dance causes Europa to flex like a rubber ball being squeezed. While the actual deformation is subtle to the eye, it generates tremendous forces within the moon. The constant flexing of Europa creates friction deep inside the moon, generating an unexpected source of heat in this frozen world. This internal friction works like a cosmic massage, warming Europa from the inside out. The process is similar to how a paper clip becomes warm when repeatedly bent back and forth. The heat generated by these tidal forces is enough to maintain a liquid water ocean beneath Europa's icy shell, despite surface temperatures hovering around -160 degrees Celsius. This isn't just a static pool of water. The tidal forces create currents and movements within Europa's hidden ocean. These ocean currents help distribute heat and nutrients throughout the water, creating conditions that might be surprisingly similar to Earth's deep oceans. The whole system works like a perfectly balanced machine. Jupiter's gravity creates movement. Movement generates heat, and heat maintains the liquid ocean. This constant source of energy might also power hydrothermal systems on Europa's ocean floor, creating environments where life could potentially thrive, much like the deep-sea vents in Earth's oceans. Beneath Europa's icy crust lies one of the most remarkable discoveries in our solar system, a global ocean containing more water than all of Earth's oceans combined. The depth of this alien ocean is staggering. Estimates suggest it could be 60 miles deep in places. That's more than 10 times deeper than Earth's Mariana Trench. With a volume of roughly twice all of Earth's oceans, this hidden sea contains enough water to fill 1 million Olympic-sized swimming pools thousands of times over. But what's in this vast ocean? Recent data suggests it's not just pure water. It's a complex soup of dissolved minerals and salts. The reddish-brown streaks on Europa's surface have given us clues about what's dissolved in its ocean. Scientists believe it contains various salts, particularly magnesium and sodium chloride, common table salt. The ocean likely interacts with a rocky seafloor, creating a chemical exchange that could provide the building blocks for life, just as we see in Earth's deep oceans. If Europa has hydrothermal vents like Earth does, they could be pumping heat and nutrients into the ocean, creating oases of potential biological activity in the darkness. Perhaps the most exciting evidence of Europa's hidden ocean comes from above. Mysterious plumes of water vapor erupting through cracks in the ice. These spectacular geysers can shoot dozens of miles into space, spraying samples of the subsurface ocean out, where future missions might be able to analyze them without needing to drill through the ice. The plumes appear to be powered by pressure, building up in subsurface chambers, periodically forcing water through cracks in the ice shell. And before we continue exploring these fascinating water jets, don't forget to hit subscribe to catch the rest of our journey through the solar system's most intriguing worlds. When scientists analyzed the chemical makeup of these plumes, they found traces of salt and organic compounds, more evidence that Europa's ocean might have the right ingredients for life. Could alien life thrive in the darkness of Europa's ocean? The answer might lie in the extraordinary creatures that inhabit Earth's most extreme environments. In the depths of Earth's oceans, life flourishes around hydrothermal vents without any sunlight. These ecosystems could serve as a blueprint for what we might find in Europa's alien sea. Europa checks all the basic requirements for life as we know it. It has liquid water, organic compounds, chemical energy from hydrothermal activity, and stable conditions that have persisted for billions of years. The potential Europan life forms would need to be masters of survival, adapted to intense pressure, complete darkness, and near-freezing temperatures. Any life in Europa's ocean would likely be microbial, possibly forming colonies around energy sources. Some might even produce their own light, similar to many deep-sea creatures on Earth. The pressure at the bottom of Europa's ocean would be crushing, many times greater than in Earth's deepest trenches. Yet on Earth, we've found microbes thriving under extreme pressures, giving us hope for Europan life. Earth's extremophiles, organisms that thrive in harsh conditions, show us how life can adapt to seemingly impossible environments. These hardy creatures might have cousins in Europa's alien waters. The search for life on Europa isn't just about finding organisms, it's about detecting the chemical signatures they might leave behind. The plumes erupting from Europa's surface might contain biological markers, specific molecules that could indicate the presence of life in the ocean below. Scientists are particularly interested in finding certain organic molecules and unusual chemical ratios that would be difficult to explain without biological activity. If life exists in Europa's ocean, it would likely form part of a complex ecosystem, with different organisms adapted to various ecological niches, from the ice-water interface to the deep ocean floor. We stand on the brink of a new era in our exploration of Europa, with ambitious missions preparing to unlock its deepest secrets. NASA's Europa Clipper mission, scheduled to launch in the coming years, will be the first spacecraft dedicated to studying this intriguing moon up close. The spacecraft will perform multiple close flybys of Europa, swooping as close as 16 miles above the surface to gather unprecedented data about the moon's composition and structure. Clipper carries a sophisticated suite of 9 instruments, including ice-penetrating radar that will peer beneath the surface and high-resolution cameras that will map the mysterious terrain in extraordinary detail. Meanwhile, the European Space Agency is preparing its own mission to the Jovian system, the Jupiter Icy Moons Explorer, or JUICE. While JUICE will primarily study Jupiter's largest moon, Ganymede, it will also make vital observations of Europa, complementing Clipper's detailed investigation. One of the most exciting objectives is to study Europa's water vapor plumes. Both missions will use multiple instruments to analyze these eruptions, potentially sampling material from the subsurface ocean. The mission's radar systems will map the structure of Europa's ice shell in unprecedented detail, potentially revealing pockets of liquid water and the true depth of the ocean below. These missions aim to answer some of our most burning questions about this enigmatic moon. Is the ocean truly habitable? What causes the surface cracks and ridges? Are those reddish-brown streaks really signs of oceanic material? These missions will help us find answers. As we prepare to embark on this new chapter of exploration, Europa continues to captivate us with its potential to harbor life beyond Earth. The discoveries awaiting us may forever change our understanding of life in the cosmos. Thanks for joining us on this journey through one of the solar system's most fascinating worlds. Don't forget to subscribe for more space exploration adventures, and let us know in the comments what other cosmic mysteries you'd like us to explore.